Do you think it's possible to automatically discover the predicates? So you basically said that the essence of intelligence is the discovery of good predicates.
Yeah.
Now, the natural question is, that's what Einstein was good at doing in physics. Can we make machines do these kinds of discovery of good predicates? Or is this ultimately a human endeavor?
Thus, I don't know. I don't think that machine can do. Because according to theory about weak convergence, any function from Hilbert space can be predicate. So you have infinite number of predicate in upper and before you don't know which predicate is good and which. But whatever prop show and why people call it breakthrough, that there is not too many predicate which cover most of situation happened in the world.
So there's a sea of predicates, and most of only a small amount are useful for the kinds of things that happen in the world.
I think that I would say only small part of predicate very useful. Useful all of them.
Right. Only very few are what we let's call them good predicates.
Very good predicate.
Right. Yeah. Very good predicates. Yeah. So can we linger on it? What's your intuition? Why is it hard for a machine to discover good predicates?
I even in my talk described how to do predicate, how to find new predicate. I'm not sure that it is very good predicate.
What did you propose in your talk?
No, in my talk, I gave example for diabetes. When we achieve some percent, so then we're looking for area where some sort of predicate, which I formulate, does not keeps invariant. So if it does not keep, I retrain my data. I select only function which keeps this invariant. And when I did it, I improve my performance. I can looking for this predicate. I know technically how to do that. And you can, of course, do it using machine, but I'm not sure that we will construct the smartest predicate.
Well, allow me to linger on it, because that's the essence, that's the challenge. That is artificial. That's the human level intelligence that we seek, is the discovery of these good predicates. You've talked about deep learning as a way to, the predicates they use and the functions are mediocre. We can find better ones.
Let's talk about deep learning.
Sure, let's do it.
I know only Jans-LeCun, convolutional network. And what else? I don't know. And it's a very simple convolution.
There's not much else to know.
Left and right.
Yes.
I can do it like that, with one predicate. It is
convolution is a single predicate.
It's single. It's single predicate.
Yes, but
you know exactly. You take Lie derivative for translation and predicate. This should be kept.
Right. So that's a single predicate, but humans discovered that one, or at least.
That is a risk. Not too many predicates, and that is big story because Jan did it 25 years ago, and nothing so clear was added to deep network. And then I don't understand why we should talk about deep network instead of talking about piecewise linear functions, which keeps this predicate.
Well, a counter argument is that maybe the amount of predicates necessary to solve general intelligence, say in the space of images, doing efficient recognition of handwritten digits, is very small. And so we shouldn't be so obsessed about we'll find other good predicates like convolution, for example. There has been other advancements, like if you look at the work with attention, There's attentional mechanisms, especially used in natural language, focusing the network's ability to learn at which part of the input to look at. The thing is, there's other things besides predicates that are important for the actual engineering mechanism of showing how much you can really do given these predicates. I mean, that's essentially the work of deep learning, is constructing architectures that are able to be given the training data to be able to converge towards a function that can approximate, can generalize well.
No,
it's an engineering problem.
No, yeah, I understand. But let's talk not on emotional level, but on a mathematical level. You have set of piecewise linear functions. It is all possible neural networks. It's just piecewise linear functions. There's many pieces.
A large number of piecewise linear functions.
Okay, exactly. But
very large.
Very large.
Almost
but
feels like too large.
It's still simpler than, say, convolution, than reproducing kernel Hilbert space, which have a Hilbert set of functions.
What's Hilbert space?
It's space with infinite number of coordinates, say, or function for expansion, something like that. So it's much richer. So, and when I'm talking about closed form solution, I'm talking about this set of function, not piecewise linear set, which is particular case of it is small part.
So neural networks is a small part of the space you're talking of functions you're talking about.
Small set of functions.
Yeah.
Let me take it that. But it is fine. It is fine. I don't want to discuss the small or big. We take advantage. So you have some set of functions. So now, when you're trying to create architecture, you would like to create admissible set of functions, which all your tricks to use not all functions, but some subset of this set of functions. Mm-hmm. Say, when you're introducing convolutional net, it is way to make this subset useful for you. Mm-hmm. But from my point of view, convolutional, it is something you want to keep some invariants, say translation invariants. But now, if you understand this, and you cannot explain on the level of ideas what neural network does, you should agree that it is much better to have a set of functions. And they say this set of functions should be admissible. It must keep this invariant, and that invariant. You know that as soon as you incorporate new invariants, set of function becomes smaller and smaller and smaller.
But all the invariants are specified by you, the human.
Yeah, but what I hope that there is a standard predicate, like prop show. Mm-hmm. That's what I want to find for digit recognition. If we start, it is completely new area. What is intelligence about on the level starting from Plato's idea? Mm-hmm. What is world of ideas? So, and I believe that it's not too many.
Yeah.
But you know, it is amusing that mathematician doing something in neural network, in general function, but people from literature, from art, they use this all the time.
That's right.
Invariants saying, say, it is great how people describe music. We should learn from that. And something on this level, but so why Vladimir Vapnik, who was just theoretical, who studied theoretical literature, he found that.
You know what? Let me throw that right back at you, because there's a little bit of that's less mathematical and more emotional, philosophical. Vladimir Vapnik. I mean, he wasn't doing math.
No.
And you just said another emotional statement, which is you believe that this Plato world of ideas is small.
I hope.
I hope. Do
No,
what's your intuition though? If we can linger on it
you know,
about
it
the
is not
space.
just small or big. I know exactly. Then when I introducing some predicate, I decrease set of functions. But my goal to decrease set of function much,
By as much as possible.
by as much as possible. Good predicate which does this. Then I should choose next predicate which decrease set as much as possible. So set of good predicates, it is such that they decrease this amount of admissible functions.
So if each good predicate significantly reduces the set of admissible functions, that there naturally should not be that many good predicates.
No, but if you reduce very well the VC dimension of the function of admissible set of function is small, and you need not too much training data to do well.
And VC dimension, by the way, is some measure of capacity of this set of functions.
Right. How, roughly speaking, how many function in this set. So you're decreasing, and it makes easy for you to find function you're looking for.
So,
but the most important part to create good admissible set of functions, and it probably there are many ways, but the good predicate is such that can do that.
so
but
let's
for this duck, you should know a little bit about duck, because
what are the three fundamental laws of ducks?
looks like a duck, swims like a duck, and quack like a duck.
You should know something about ducks to be able
Not
to.
necessarily. Looks like, say, horse. It's also good.
So it's not. It generalizes
Yes,
from ducks.
and talk like and make sound like horse, something, and run like horse, and moves like horse. It is general. It is general predicate that this applied to duck, but for duck you can say play chess like duck.
You cannot say play chess.
Why
like
not?
duck. So you're saying you can, but that would not be a good.
No, you will not reduce a lot of functions.
You would not do. Yeah, you would not reduce the set of functions.
So you can. The story is formal story, mathematical story, is that you can use any function you want as a predicate. But some of them are good, some of them are not, because some of them reduce a lot of functions to admissible set. Some of them.
So, but the question is, and I'll probably keep asking this question, but how do we find such what's your intuition? Handwritten recognition. How do we find the answer to your challenge?
Yeah, I understand it like that. I understand what means,
defined?
what it means. I knew predicate.
Yeah.
Like guy who understand music can say this word which he described when he listened to music. He understand music. He use not too many different. Oh, you can do like prop. You can make collection. What he talking about music, about this, about that. It's not too many different situations he described.
Because we mentioned Vladimir Vapnik a bunch, let me just mention there's a sequence of 31 structural notions that are common in stories, and I think
he called units,
and I think they resonate. I mean, it starts, just to give an example, abstention. A member of the hero's community or family leaves the security of the home environment. Then it goes to the interdiction. A forbidding edict or command is passed upon the hero. Don't go there. Don't do this. The hero is warned against some action. Then step 3, violation of interdiction. Break the rules. Break out on your own. Then reconnaissance. The villain makes an effort to attain knowledge, needing to fulfill their plot. So on. It goes on like this. Ends in a wedding. Number 31.
Yeah.
Happily ever after.
No,
right?
he just gave description of all situations. He understands this world.
Of folk tales.
Yeah, not folk
stories.
But stories. And this story is not in just folk tales. the stories in detective serials as well.
And probably in our lives, we probably live.
Read this. At the end, they wrote that this predicate is good for different situation. From movie, for movie, for theater.
By the way, there's also criticism, right? There's another way to interpret narratives from Claude Lévi-Strauss.
I don't know. I'm not in this business.
I know it's theoretical literature, but it's looking at paradigms behind
it's always they have a discussion.
Argue. Yeah.
But at least there is a units. It's not too many units that can describe, but this guy probably gives another units or another way of
exactly another set of units,
another set of predicates. It does not matter how, but they exist probably.
My question is whether, given those units, whether without our human brains to interpret these units, they would still hold as much power as they have. Meaning, are those units enough when we give them to an alien species?
Well, let me ask you, do you understand digit images?
No, I don't understand.
No. When you can recognize these digit images, it means that you understand.
Yes,
you understand characters, you understand.
Nope. It's the imitation versus understanding question, because I don't understand the mechanism by which I
No. I'm not talking about. I'm talking about predicates. You understand that it involves symmetry, maybe structure, maybe something else. I cannot formulate. I just was able to find symmetries, so degree of symmetries.
That's really good. So this is a good line. I feel like I understand the basic elements of what makes a good hand recognition system my own. Like symmetry connects with me. It seems like that's a very powerful predicate. My question is there a lot more going on that we're not able to introspect? Maybe I need to be able to understand a huge amount in the world of ideas. Thousands of predicates, millions of predicates in order to do hand recognition.
I don't think so.
So both your hope and your intuition are such that very few predicates are enough.
You're using digits, you're using examples as well. Theory says that if you will use all possible functions from Hilbert space, all possible predicate, you don't need training data. You just will have admissible set of functions which contain one function.
Yes. So the trade-off is when you're not using all predicates, you're only using a few good predicates, you need to have some training data.
Yes, exactly.
The more good predicates you have, the less training data you need.
Exactly. That is intelligent learning.
Still, okay. I'm going to keep asking the same dumb question. Handwritten recognition. To solve the challenge, you kind of propose a challenge that says we should be able to get state-of-the-art MNIST error rates by using very few, 60, maybe fewer examples per digit. Yeah. What kind of predicates do you think it will look like?
That is the challenge. So people who will solve this problem,
they will answer.
They will answer.
Do you think they'll be able to answer it in a human explainable way?
They just need to write function. That's it.
But so can that function be written, I guess, by an automated reasoning system? Whether we're talking about a neural network learning a particular function or another mechanism.
No, I'm not against neural network. I'm against admissible set of functions which create neural network. Right. You did it by hand. You don't do it by invariants, by predicate, by reason.
But neural networks can then do the reverse step of helping you find a function. The task of a neural network is to find disentangled representation, for example, is what they call, is to find that one predicate function that's really captures some kind of essence. One, not the entire essence, but one very useful essence of this particular visual space. Do you think that's possible? Like, listen, I'm grasping, hoping there's an automated way to find good predicates, right? So the question is, what are the mechanisms of finding good predicates, ideas that you think we should pursue? A young grad student listening right now.
I gave example. So find situation where predicate which you're suggesting don't create invariant. It's like in physics. Find situation where existing theory cannot explain it.
Find situation where the existing theory can't
explain this.
So you're finding contradictions.
Find contradiction, and then remove this contradiction. But in my case, what means contradiction? You find function, which, if you will use this function, you're not keeping invariants.
So really, the process of discovering contradictions.
Yeah. It is like in physics. Find situation where you have contradiction for one of the property, for one of the predicate. Then include this predicate, making invariants, and solve again this problem. Now you don't have contradiction. But it is not the best way, probably, I don't know, to looking for predicate.
That's just one way. Okay.
No, it is brute force way.
The brute force way.